So good morning, students. So last class we had discussed about some of the basics of serial communication. So we have two types of communication: serial data transfer, that is two types of data transfer, serial data transfer and parallel data transfer. So here the fastest way of transmitting data within microcontroller is parallel data transfer. So for transferring data over long distances, however, the parallel data transfer, that is transmission, requires too many wires. Okay, so therefore for long distance data communication, usually the data is converted from parallel form to serial form, so that it can be sent on a single wire or pair of wires. Similarly, the data received from the distant source, that is your receiver, is converted to parallel form to serial form, so that it can be easily transferred on your microcontroller buses. Okay. So according to the communication, there are three types: simplex communication, half duplex communication, and full duplex communication. So simplex means a single data line can transmit data only one direction. Okay. And half duplex means in the half duplex, the communication link can be used for either transmission and reception. So data is transmitted in only one direction at a time. And full duplex, data is transmitted in both the ways at a time. So transmission and reception can proceed simultaneously. So the communication link requires two wires of data, one for transmission and other one is for reception. Okay. And coming into the data format, so actually we have two types of that is serial communication uses two methods. One is asynchronous and another one is the synchronous. So asynchronous method transfers a block of data at a time, that is a block of characters at a time, while asynchronous method transfers a single byte at a time. So most of your microcontroller follows, that is follow the technique of asynchronous way of communication. So the format followed for asynchronous way of communication, this is the format. It initially starts with start bit and your 8-bit data or character. So your LSB goes out first and along with your stop bit and space. Okay. So the data transfer rate is measured in terms of baud rate. Baud rate, the unit for baud rate is bits per second. So what is baud rate? It is a very important terminology of serial communication. So what is baud rate? What is baud rate? Can anyone explain that? So baud rate is a modern technology. It's a bit transmission rate. Very good. So it is a reciprocal of the time to send one bit of data. Suppose if the baud rate is set to 9600 means that is 9600 bits are transmitted in 1 second. So your transmission time is calculated by using formula, that is 1 second divided by 9600. So transmission time is 0.14 millisecond. Okay. So it is a very important parameter in your serial communication. So this baud rate can be generated by using timers. It's a programmable baud rate. Your 8051 supports programmable baud rate, and also it has an inbuilt UART. The inbuilt UART means universal asynchronous receiver and transmitter. Okay. So coming into this slide, the communication between your 8051 to your personal computer. Okay. So here, to allow data transfer between your PC and 8051 without any error, so we must make sure that the baud rate of 8051 matches with the baud rate of baud rate of PC's COM port. Okay. So we have to check the baud rate of your 8051 should be matched with the baud rate of your personal computer COM port. So your baud rate in 8051 is a programmable one. Okay. With the help of timer 1 in mode 2. It is a 8-bit auto reload. And here So as we know, your 8051 frequency, it is internally divided by 12. Again, it is divided by 32 by using your UART. Okay, so UART divides the mission cycle frequency by 32. So that clock pulses are given to your timer 1 model to generate baud rate. Okay. So next one is the S buffer register. That is one of the special function register in serial communication. So we have two pins for transmitting and receiving data, that is TXT and RXT. So TXT is your P3.5. So this will perform data transmission, okay? And P3.3 is RXT. This will perform reception. So your data transmitted out of 8051 is through this P3.1 via TXT. Similarly, data receives from external devices to microcontroller via RXT. So S buffer is a 8-bit register. So it can be accessible like any other register, that is general purpose register like your accumulator and B register. So move F buff hash D. So this is character. So the character to be received. Okay. So this character is placed in S buffer register. So the size of this S buffer is 8-bit register. So it's a 8-bit register. Again, we can transfer the accumulator content to S buffer and S buffer to accumulator. Okay. So this will perform only 8-bit data transmissions because since it is a 8-bit register. And this is a block diagram of your S buffer. S buffer is physically two register. One is write only register, other one is the read only register. Okay. So this write only is used to hold the data to be transmitted out of 8051 via TXT. Similarly, other register is the read only. We have two registers. Okay. So these two registers are internally connected to your internal data bus of 8051, and each register has one shift register. Okay. So during the transmission, the data will be placed on FBUF register. So the duty of SBUF is to pack the data. That is 8-bit data was packed with your start and stop bit. So your byte of data to be transferred via TXT line. So it must be placed in S buffer register. So once the moment the data is returned into S buffer, it is framed with start bit, stop bits, and transferred serially via TXT. Okay. So framed with start and stop bits and transferred serially via TXT. Similarly, during the reception, the 8051 reframes it by eliminating start and stop. And then placing it in S buffer register. So it's received through this shift register. So the functionality of shift register is to deframe the data by eliminating start and stop bit. Only your S buffer can hold 8-bit data or character alone. Okay. So the main thing is the read only holds received data from the external devices via RXT, and both the registers are mutually exclusive. Use address single address 99. It's a single register. So both the registers are mutually used, exclusive registers. Okay. So any doubts in S buffer? So it's a very important register. whatever data you want to transfer or receive, you have to place that 8-bit data in SBUF register. So physically two register, okay, one is read only, other one is the write only. Any other doubts regarding this? So write only is for, that is, it is used to hold the data to be transmitted out of 8051 via TXT. Read only that holds received data from external devices or sources via RXT. Okay. So these two are mutually exclusive register because since it is using a single 8-bit address, that is 99 is used for both transmission and reception. Any other doubts regarding this S buffer? So this slide is very important. So this one represents your baud rate calculation. So your 8051 transfers and receive data serially at different baud rate levels. That is 9600. You can see here. So different baud rate it can support 9600, 4800 and 2400 and 1200. So this baud rate is programmable one. Okay. So this is done with help of timer 1 register. That is timer 1 8-bit auto reload. So as discussed previously, that is in previous chapter, your 8051 crystal oscillator frequency is divided by 12 to get the mission cycle. Mission cycle frequency is 921.6 kilohertz. Okay, so that is 11.0592 is internally divided by 12. So the mission cycle frequency is 921.6 kilohertz. So in 8051 has inbuilt UART. So again, this value is divided by 32, okay, to set the baud rate. So we will be getting 28,800 hertz. Okay, so this frequency, so this amount of frequency is given to your timer 1 model to set the baud rate. Okay, so for that we have a calculation here. Please look at this one. So your frequency is 11.059 megahertz. We have to find the initial value of the timer for the following baud rates. That's 9600, 2400 and 1200. Okay. So the mission cycle is 11.0592 divided by 12, 921.6 kilohertz. Again, this frequency is divided by your UART module by 32. So we will be getting 28,800 hertz is the frequency provided by UART to timer 1 to set the baud rate. Okay, so for that you have to divide this value by 3. We will be getting 9,600. So the initial value of the timer is your minus 3. That is minus 3 is nothing but 256. So 28,800 divided by 3. Okay, so this 3 is subtracted from your maximum value of timer 1, that is 256 minus 3. So the value is 253. So this should be the initial value of your timer to generate this 9,600 baud rate. So what is the hexadecimal equivalent for 253? FD. So this FD should be loaded into TH1. Similarly, to get a baud rate 2400, you have to divide this value by 12. So this 12 should be subtracted from your maximum value of the timer. So the hexadecimal value FO. So this value should be loaded into TH1 in order to get a baud rate 2400. Similarly, divide by 24. So 256 minus 24 is equal to E8. So this value should be loaded into TH1. So in this way, we can set the baud rate by using timer 1. Okay, so when timer 1 is used to set the baud rate, it must be programmed in mode 2 and 8-bit auto reload mode. Okay. So please note down the values. This table is very important. for writing applications using serial communication concepts. So for 9600 baud rate, this is the value. So you have to, while programming your serial communication, first you have to set the baud rate, otherwise data cannot be transferred from 8051 to your external device. So you have to set the baud rate, that is the initial step. So you have to load this value into TH1. Similarly, for setting 4800 baud rate, FA should be loaded into TH1. For setting 2400, FA should be loaded. 1200, E8 should be loaded. Please note down the values. So next register is a very important register, that is serial control register. It is one of the special function register of your serial communication. It is also a 8-bit register with bit addressable mode. So we can access individual bits. So 8-bit register, bit addressable from D0 to D7. So first we start with these two bits, SM0 and SM1, that is D7 and D6. So these two bits define modes of operation, serial modes. Okay. So please look at this table. SM0, SM1, operating mode, serial mode is 0. 0, 1, 1, 1, 0, 2, 1, 1, 3. Okay. So the first one supports half duplex communication. Half duplex synchronous data transfer. So remaining 3 will provide full duplex communication plus asynchronous way of data transfer. So mode 0 is a half duplex mode. It is a shift register mode. So your baud rate is divided by, that is your baud rate can be calculated by dividing your external oscillator frequency by 2. Okay, that is your baud rate is equal to F by 2. That is the meaning. So your transmission rate, baud rate is equal to F by 12. F is nothing but your oscillator frequency. It is a fixed one. It is not a programmable. Okay, it is a fixed one. So this mode is called shift register mode. And next mode is the 8-bit UART mode. Okay, it is a 8-bit UART mode, means your data is packed with start and stop bit. Okay, and your baud rate can be generated by using your timer 1 based on this calculation. Okay, based on this calculation, it is a programmable one. So your baud rate is variable. So this is done by using your timer 1 in auto reload mode. Okay, and next one is the 9-bit UART mode. So here baud rate is either can be F by 32 or F by 64. Either 32 or 64. Only we have two options. So here 9-bit means 8-bit of data with parity. That is the meaning. 8-bit means start plus 8-bit data stop. So it follows 10T format, 8 plus 1 plus 1, 10T. 10T means 10 clock cycles. It requires 10 clock cycles to transfer single byte of data. Start bit plus 8-bit data plus stop bit. 9-bit means start bit, 8-bit data, stop bit along with parity. So this format follows 11T. 11T means 11 clock cycles are required to transfer or receive 8-bit data. So that data transmission mode is called 9-bit UART mode. Here baud rate is fixed XTAL divided by 32 or XTAL divided by 64. And next one is the 9-bit UART mode, that is similar to your mode 1. Here baud rate is variable. So we have 4 modes. One is the shift register mode. Second one is the 8-bit UART mode with variable timer. And third one is the second mode is the 9-bit UART mode. Here your baud rate can be either 80, that is XTAL divided by 32 or XTAL divided by 64. And third mode will be a 9-bit UART mode. It will follow 11T format. Okay, 11T format, and your timer, your baud rate is variable. That is programmable by using your timer. It's very similar to your mode 1. Okay. Any doubts related to this? Any doubts regarding this modes of operation? So shift register mode supports, that is provides only half duplex communication. So that mode is not widely used. And most of the application we are using mode 1, that is 8-bit UART mode, that is variable timer 1. So mode 1 is taken into consideration for all the applications because it supports full duplex communication and your baud rate is variable. We can program the baud rate by using timer. And third important feature is this will provide asynchronous data transfer. Okay. And here SM2, that is used for multiprocessor communication. So here only one microcontroller is involved in application. So for all the programming concepts, we will make this bit as 0. SM2 is not used in 8051 since it is involved in only one microprocessor, not a multiprocessor environment. So we will make this bit as 0. Next, receive enable. So when this bit is 1 means the complete reception, entire reception is enabled, otherwise blocked. 0 means your reception is blocked. So if the bit is 0, your microcontroller is not able to receive data from the external devices. So it is a programmable one. And next, these two bits are very important, TB8 and RB8. TB8 is transmit bit 8 and RB8 is receive bit 8. Okay. So the TB8 holds, okay, bit 8 of transmitted data in mode 2 and 3. So since mode 2 and 3 are 9-bit UART, okay, 9-bit UART. So 8-bit data holded by SBUF register, okay, and parity bit will be holded by this TB8. Do you understand? So your mode 2 and 3, okay, will perform 9-bit data transfer and reception. So on SBuffer sizes, it can accommodate only 8-bit data. So 8-bit will be transferred to SBuffer register and parity bit is transferred to TB8. Okay. And in case of receive byte, actually this is also used in mode 2 and 3 during the reception. And also it is used in mode 1. Your stop bit of mode 1 goes into RB8. Stop bit. Stop bit of mode 1. Please note it down. This is very important. So during the transmission, your mode 3 and mode 2 and 3, ninth bit is transferred to TB8. That is TB8 holds the data, that is ninth bit of data in mode 2 and 3. Okay. And similarly, In receive, it holds bit 8 of received data in mode 2 and 3, and also it holds stop bit in mode 1. Okay. So these two bits are mainly used in 9-bit data transmission. In mode 1, it will hold stop bit in case of RB8. Okay. And next one is the TI, transmit interrupt flag. So these two flags will generate interrupt signal in order to interrupt your 8051 operation. So TI is transmit interrupt flag. So suppose your 8051 finishes the data transfer. Suppose if it is, if the data bit is, that is your data 8-bit data is completely transferred, means this flag is set to 1. Okay. If the data available in the SBUF register is completely transferred, means this flag is set to 1 to indicate that it is ready to transfer another byte of data, which means that if the data was completed completely, that is, if the data was transmitted completely, your S buffer is empty. So your F buffer register is empty. So this TI is set to 1 means to indicate that S buffer is empty. It is ready to transfer another data byte. That is the meaning of this TI flag. Suppose if the RI, actually this TA bit is raised at the beginning of stop bit. Okay, this TA is raised at the beginning of stop bit. RI means when the 8051 receives data serially via RxD. Okay, so all the bits are transferred to, that is placed in S buffer register. Okay, that case your RI flag is set to 1 to indicate that the byte has been received and should be picked up before it is lost. That is the meaning, which means that your S buffer is full. So TI to indicate that S buffer is empty, RI to indicate that S buffer is full. So based on that, your microcontroller either place the data into S buffer register or pick the data from the S buffer register. Do you understand that? So during the transmission, when the data byte is completed, transmitted out of your 8051, that case your S buffer register is empty. Okay. So at that moment, your TI flag is set to indicate that your microcontroller is ready to transfer the another data byte, which means that your S buffer register is empty. Okay. Next case, in case of receive interrupt, when the data byte is received, means it will be placed in S buffer register. So that at that moment your RI is set to 1 to indicate that S buffer is full, and also that data should be picked up before it is lost. So that is the meaning of TI and also RI. Any doubts regarding this? So we have two registers, the 2 bits to set your serial modes. So we have 4 modes, mode 0, mode 1, mode 2 and mode 3. And SM2 was used for multiprocessor communication. So we will make this bit as 0, and REN is for enabling your reception. If it is 1, your reception is enabled, and 0 means your 8051 is not able to receive any data byte from the external devices because your reception feature is completely blocked by this bit. And TB8 and RB8 is for 9-bit UART communication. TTA is a transmit interrupt flag. It is used to indicate that S buffer is empty. So it is ready for your 8051 is ready for transferring the another data byte. When RA is set to 1 means the S buffer is full. So 8051 has to pick up the data from the S buffer register. Okay. So that is the purpose of TI and RI. Any other doubts here? Any other doubts? Students, please respond. So most of our application we are choosing mode 1, 0, 1. This is 0, 1. You make this 0, 0, 0, 0 because TA is set by hardware. Once the TA is set to 1, user responsibility is that is it's a programmable one. Using software, we have to clear that bit value. Okay, 0, 1, 0, 1, remaining all 0. TA and RI is automatically set by hardware based on your transmission and reception. So your SCON value will be 50. So for all the programs, the first step, you have to initialize your SCON. So the initial, that is the initial value of SCON is 50. So SCON is initialized to 50. So next to register is power control register. So here in power control register, it is a very important bit involved, that is SMOD bit, serial baud rate modifier bit. Please note it down. Serial baud rate modifier bit. So suppose this SMOD is 1 means by program to double the baud rate using timer 1 for all the modes. That is 1, 2, 3 serial modes. We can double the baud rate by using this SMOD. Suppose if your SMOD is 0, by program to use timer 1 for baud rate generation. It's a general default thing. SMOD is 0 is a default operation. So your baud rate is generated by using timer. If it is 1 means your baud rate is doubled. So if SMOD is equal to 1, your baud rate is doubled, and this PCON register is not a bit addressable register. Okay, so your PCON is not bit addressable register. So to modify this SMOD bit, we have to use these 3 instructions. Since it is a bit addressable register, you have to move the current status of PCON to accumulator. Okay. And set your 7th bit of accumulator. 7th bit means from D0 to D7. So make this bit as 1, okay, and move your accumulator content to PCON. So your SMOD is set to 1. So these 2 instructions must be used to set your SMOD. Are you able to follow? So it is not a bit addressable register, so we cannot modify the SMOD bit directly. For that, first you move the content of PCON to accumulator and make the 7th bit of accumulator to 1, set to 1, and again write the accumulator content to PCON. Now your SMOD is modified into 1. So if SMOD is equal to 1 means your baud rate is doubled. Any doubts regarding this SMOD bit? It's a very important bit in your serial communication. So this diagram explains how your baud rate is doubled. Okay. So here external oscillator circuit. Okay. Already I explained this. It is divided by 20. So your mission cycle frequency 9 to 1.6 kilohertz. If SMOD is 0, according to the architecture, the UART circuitry divides this mission cycle by 32. Okay. So this is the default value, 28,800. So this can be generated by using your timer 1 model. Okay. Suppose if we set this SMOD is equal to 1 means it is divided by 16 alone. We have 2 options, either divide by 32 or UART divides the mission cycle frequency by 32 or 16. If the frequency is divided by 16, we will be getting this 57,600. So this value is doubled. 28,800 into 2, we will be getting 57,600 baud rate. So look at this table. if the baud rate is 9600, it's a default value when S mod is equal to 0. Suppose if S mod is equal to 1, the value is doubled. Similarly, 4800, 9600, 2400, 4800, 1200, 2400. So this is the internal block diagram for doubling the baud rate by using S mod bit. So using 8051 architecture, we can set the baud rate at the maximum of 19,200. Is that clear? So it's a very important bit. Your MSB is S-mod. Remaining 3 bits, that is your D6, D5 and D4 not used. That is reserved for future implementation. And these 2 flags are user flag, GF0 and GF1. So in PSW, we have 1 user flag. Similarly, in PCON, we have 2 user flags, GF1 and GF0. So user can set or reset the flag bits. It's a programmable one. And D1 is power down. It's mainly for power consumption bit. It's a power down bit, and this is ideal mode bit. So these 2 bits are mainly focusing on power reduction. Power reduction. So in our application, that is in serial communication programs, mainly we are focusing on SMOD. Just ignore remaining all the bits, not at all used. You have to concentrate this SMOD alone for doubling the baud rate. Okay. So any other doubts up to this? We have any doubts regarding your SBUF register, SCON register and PCON register? Any doubts regarding this? Okay. So look at this diagram. So each diagram defines the mode of operation. So first one is the mode 0. Here mode 0, what is the operation? It is a shift register mode. Shift register mode. It is similar to your 8051 internal oscillator operation. That is your on-chip oscillators divided by 12. The baud rate clock is, that is your oscillator frequency divided by 12. Okay, is that clear? And next one is mode 2. Okay, this diagram explains mode 2. So it depends on S mod 0 and S mod 1. So here you can see mode 2 is a fixed one. It's not a variable baud rate. External oscillator frequency divided by 32, external oscillator frequency divided by 64. So based on S mod is 1, it is divided by 32 or divided by 64. Sorry, divided by 64. Mode 1 and mode 3 are very similar. Okay, so mode 1 follows 10T format, mode 3 follows 11T format. Okay, so based on S mod, it is divided by 32 or divided by 16, and based on this S mod bit, the baud rate clock will be generated. So here timer 1 overflow based on that. Timer 1 overflow. We will see one by one. So first one is the mode 0. So here, this diagram, your TXT is connected to clock and RXT is connected to data. So your SM0 and SM1 is equal to 0 configures S buffer to receive and transmit 8-bit data bits using pin RXT for both functions. Both transmission and reception will be performed by this RXT. Okay, and TXT pin is used to output the shift clock pulses. So 8-bit data are transmitted and received. So LSB is transmitted first. So TXT outputs the shift clock pulses to your shift register. Only 8-bit data are transmitted or received. LSB is the first. So your baud rate is fixed 1/12 of the crystal oscillator frequency. So this port runs in synchronous mode. So this mode runs in, that is serial port runs in synchronous mode. So your data is transmitted and received by RXT pin, and TXT is used for clock output. So the application is only port expansion. So it will provide the port expansion, that is it will improve the 8051 port capability. Additionally, using this block we can get 8-bit data lines. So mainly it is applicable for port expansion, not for transmission and reception. Okay. Any other doubts? The communication, half duplex communication, the method, synchronous method. Here only one pin is used for transmission and reception, that is your P3.3, that is RXT. So 8 bits are transmitted and received. A very simple mode. Okay. Mode 1 is very important. 10 bits are transmitted. 10 bits means your start bit, 8-bit data and stop bit. So 10-bit full duplex receiver transmitter. That is the meaning. So full duplex transmitter and receiver. So 10 bits, that is along with your 8-bit data, stop bit and stop bit. And the reception, the original 10-bit data, start bit is discarded, 8-bit data goes into SBUF register, and stop bit is saved in bit RB8 of SCON. Stop bit goes into RB8 in SCON. 8-bit is transferred to your SBUF register, and start bit is discarded. And baud rate is determined by timer 1 overflow rate. So already I have explained, divided by 12 and divided by 13. This is the frequency to generate, that is set your baud rate clock pulses. Okay. So it can be programmed as 1/16 of mission cycle. That is based on S mod. That is your timer overflow flag, that is overflow rate divided by 16, or timer 1 overflow rate divided by 13. Based on S mod, it can be programmed. Okay. So transmission is initiated by any instruction that uses SBUF register as a destination register. Okay. So during the transmission, 10-bit full duplex data, 10 bits have been sent. It is start bit, 8-bit data and stop bit. At reception, the start bit is discarded, 8-bit data go into your SBUF register, and stop bit is saved in bit RB8 of SCON register. Okay. So this is a calculation, baud rate calculation in mode 1. So this formula is very important. Please note it down. That is your F baud rate is equal to 2 power of S mod divided by 32 into oscillator frequency divided by 12. Okay, the 32, 12, already you know the significance of 32 and 12 into the maximum value of the timer 1, 8-bit auto reload is 256 minus TH1. So here we know the baud rate. Okay, so already we have known the baud rate. And using this formula, we have to identify the initial value of your timer. So TH1 is equal to 256 minus, here baud rate S mod is default value 0. So 2 power 0 divided by 32 into oscillator frequency divided by 12 into 9600. So the value is 253. So the FD should be loaded into TH1. So this is the formula to be used for calculating your baud rate. Suppose 4800. Please find out the value. Here I am placing 4800. So what is the value? Please calculate. So I want to generate 4800 baud rate. For that, I need to find out the initial value of timer by using this formula. So instead of 9600, you have to use 4800. What is the value? Please tell me. FA, very good. Decimal equivalent. Rohit, the decimal equivalent for FA. So what is the decimal equivalent of FA? 250. Okay. So this table is calculated by using this formula. That is 2 power S mod divided by 32 into oscillator frequency by 12 in bracket 256 minus TH1. So based on the formula, your value, initial value of the timer can be calculated. Okay. So that's all about your mode 1. Mode 1 is very important. Okay. Mode 2. In mode 2, it's 11-bit transmission. 11 bits are transmitted and received. Via TXT and RXT. So your 11 bits include start bit, 8-bit data, and programmable 9th data bit and stop bit. So here 9th data bit is your parity bit from PSW. Here parity bit from PSW. Actually in PSW we have one option, parity option. Okay. So that parity bit from PSW can be moved into TB8 for transmission as the 9th bit. So this bit is the programmable 9th bit. Okay. And stop bit. So on transmit, 9th bit TB8 can be assigned. It's a programmable one, 0 and 1. On receive, 9th data bit goes into RB8 in SCON register. So your 9th bit can be parity bit. So from your PSW, here baud rate is programmable, either 1 by 32 or 1 by 62 of oscillator frequency. And mode 3 is similar to your mode 2, but may have variable baud rate generated from timer 1. So this one supports 9-bit full duplex transmission and reception. So that's all about your modes of operation. So we have 4 modes. Mode 0 is a half duplex synchronous mode communication. 8 bits data are transmitted and received. A single data line can be used for both transmission and reception. And mode 1, 10 bits are transmitted and received. So start bit, 8-bit data and stop bit. Okay. So this is the formula for calculating your baud rate. And mode 2 is a 11-bit data transmission. Start bit, 8-bit data, programmable 9th data bit and stop bit. And mode 3 is very similar to your mode 2, but may have variable baud rate based on your timer 1. Okay. So next we will see the algorithm for transmitting data, that is programming serial data transmitting. So in programming 8051, to transfer the character byte serially, so we have to use timer 1 in mode 2. Okay. So for that, calculate the initial value of T mod value. So timer 1 in mode 2. So the value is 0, 0, 1, 0. Timer 1, remaining all the bits are 0. So this value is fixed to set the baud rate. So first step is T mod register is loaded with 20, indicating the use of timer 1 in mode 2 to set the baud rate. Okay. And next TH1 is loaded with one of the values to set the baud rate. Okay. Either 9600 or 4800. And third step will be SCON register. So the SCON register is loaded with the value of 50, indicating serial mode 1. It is a 8-bit data. It's framed with start and stop bits. So these three are initial steps. So first you have to initialize your T mod value and TH1 value in order to generate baud rate. Third one, SCON value. Okay. Next you have to start the timer to generate baud rate clock frequency. Okay. So once timer gets started, you have to monitor your TI. Okay. So first initially clear TI and write the data into SBUF register. Suppose I want to transfer character A. Okay, you have to transfer this character to SBUF. Now your SBUF register is filled. That is SBUF is full. Okay, so from SBUF, the data is transmitted out of 8051 via TXT. Once SBUF is empty, your TA is set to 1. So first write the character into SBUF register and monitor the TA flag continuously to indicate that SBUF is empty. If the SBUF is empty means your TA flag is set to 1. Okay. So after that you have to clear the TA flag and go to the step 2 to transfer the next byte of data. Step 5. Sorry, step 5 to transfer the next byte of data. Please note down the algorithm steps. So load T mod value, next TH value and SCON value, start your timer and move the character into SBUF register, monitor the TA flag. Once TA flag is set to 1, okay, and clear the TA flag and transfer the next data. That is, repeat the same steps, okay. So here write a program for 8051 to transfer letter A serially at 4800 baud rate continuously, okay. So what is the first step? So first step, move T mod, #20 to set your timer 1 in mode 2. And next, TH1 value. What is the TH1 value for 4800 baud rate? Please tell me. So what is the TH1 value? -6 or FA. Very good. FA. #FA. So next step, move SCON #50. So all the values are initialized. Next, we have to start the timer. Set bit TR1. And what is the next step? We have to load the character into SBUF register to initiate the data transfer. So move SBUF, #character A. So our microcontroller will start sending the data from SBUF to external device via TXT. Okay. After that, continuously monitor overflow, transmit interrupt flag. So when TA is equal to 0 means keep on checking the TA status. If it is 1 means we have to, that is your data byte is transferred completely. So that case your SBUF is empty, and to indicate that your 8051 is ready to transfer another data byte. So for that you make TI is 0. So clear TI and repeat the process. L2 come here. Please note down the steps. Is that clear? First load your T mod with 20, load your timer 1, the higher order register with F8 to generate 4800 baud rate, and initialize your SCON register with selecting your mode 1 serial port mode, start the timer and transfer the character into SBUF register. Once the transfer is completed, when the character is transferred completely, your TI flag is set to 1. So when TI is set to 1, clear the TI and repeat the process to initiate the next data transfer. Any doubts regarding this? Students, please reply. Okay. So run this code with KEIL microvision. SMOD TH is initialized and timer gets started. The character A is placed in SBUF register, continuously monitoring the timer interrupt, the transmit interrupt. So when TI is set to 1, clear TI for next data transfer. So here you can see on the peripherals, we have a separate window for monitoring your serial modes. Okay, it's a serial channel. Okay, here we have 4 modes: 8-bit shift register mode, 8-bit variable baud rate, 9-bit fixed baud rate, 9-bit variable baud rate. And using this provision, we can monitor our TI and RI flags, transmit interrupt and RI flag, and also your baud rate values. Here SMOD and baud rate value. Okay, and also we have one serial window, that is UART window. Open the serial window. So here we can visualize all our transmission and reception. Okay, so let's run this code. You can see the character A is continuously displaying on UART window. At the same time, your timer is counting the clock pulse based on your baud rate frequency. So here baud rate is set approximately nearly to 9600. Here FD, what is it? FD, it's a 9600. Suppose FA means it's a 4800. So your SCON is initialized with 50 and buffer register we have 41. So the ASCII equivalent for character A is 41. So your S buffer holds 41 here. In Proteus, we have a separate component to monitor your transmission, that is virtual terminal. So this component provides two signal RXT and TXT. So the RXT should be connected to the TXT of virtual terminal, that is RXT of your 8051. Similarly, TXT of 8051 should be connected to RXT of virtual terminal. Okay. So you can see A is continuously transmitted out of 8051. So before execution, you have to set the baud rate here. You have to set the baud rate 9600 and data bits and parity none, stop bit 1. Okay, you have to set all these parameters. Similarly, in microcontroller side, you have to fix this 11.059 megahertz instead of 12 megahertz. You have to set this frequency to get a proper output. Okay. See, so the homework problem, you have to write a C code for this particular application. Okay, write a program for 8051, embedded C program for 8051 to transfer letter A serially at 4800 baud rate. Okay. And second problem is reception. So only thing is first three steps will be same. TMOD, initializing TMOD, TH1 and SCON register, start your timer, and you have to monitor your RI flag continuously. When RI is set to 1 means your SBUF register has a character, okay? So you have to transfer that character from SBUF register to general purpose register in order to view your reception. So first 4 steps will be same. After that, you have to monitor your RI flag. When RI is set to 1, the character is available in SBuffer. Move that SBuffer into general purpose register. So first homework problem, you have to convert this program into embedded C. Second one, write assembly code for this particular application. That is to receive bytes of data serially and put them in P1. Set the baud rate at 4,800. Please note it down tomorrow. Okay, I'm going to ask questions related to that. Based on that only, I will mark attendance. So you are not concentrating on programming side. It's very important concepts. Okay. So write assembly program for reception. Okay. Similarly, convert that assembly into embedded C. So next class, we are going to discuss about transmission embedded C program, reception assembly, as well as embedded C. So the Friday, I am planning to conduct a test for Unit 2, okay? 50 marks objective test and 15 marks descriptive. It's a combination of both objective and descriptive. Okay. Descriptive question, it's similar to your midsem questions. It consisting of two 2 marks and 1 11 mark. Either are choice. And 15 objective question. Either Friday or Saturday. Okay. Please be prepared. So almost your second unit is completed here. Okay. Next class we will discuss the answers for this particular problem, and straight away we start the third unit. Okay. The third unit is about interfacing peripheral devices. So it will cover some of the ICs, that is 8255 and 8259, and keyboard and display control. Okay.